Well, hello, I'm Jeffrey Palermo, and I'm the Chief Architect of ClearMeasure, and we're a DevOps-Centered Software Engineering firm serving the greater United States. And over my 2 decades of working with custom software, I've seen scores of modernization projects. And I know the challenge that an aging system poses. And so today, I'm going to show you a faster path to software modernization, regardless of which of the three major strategies that you choose. And I know how busy you are, and my goal is to get you out of here in 30 minutes. So let's get started. Okay, so for today's webinar, you can chat amongst yourselves using the chat windows. And if you wouldn't mind, would someone please confirm that my audio is coming through loud and clear in the Zoom chat window? You can ask questions through the Q&A window, and I'll make sure that all questions do get answered either during the webinar or at the end. And so the audio feedback, thank you for that. So feel free to ask questions in the Q&A window, and I'll make sure to get to them. Okay. So we are going to talk about the challenge of aging software and why we find ourselves in need of modernization. And then we'll explore some symptoms of an aging system and look at an overall roadmap of how to plan your modernization, including available strategies, the details of each strategy, and then the value that you provide when executing and how soon you can provide value. And at the end, we'll share some ways that we can be of assistance to you in your modernization initiative. Okay, so you might call it a legacy system or something else. It's a very common term, an aging system, legacy system. The system's hard to change. It's gotten risky. But a system generally that is showing its age is not resilient to change any longer. And when it goes down or has stability issues, business disruptions occur. And these systems are important, really, really important. These systems are no longer able to change at the pace or in the way that's necessary for your organization to execute its go-forward strategy. And when the system starts holding you back, then you have to address it, okay? So let's dive into the problem just a bit. We have an aging system, a legacy system. It could be an old platform. Certainly COBOL mainframe systems are called legacy systems, but there are many clients actively doing fresh development COBOL systems, doing well with it. I mentioned that to illustrate that an older platform in and of itself and alone doesn't cause a system to produce business delays or business disruptions, but an old platform may be a symptom that you're seeing, and it may be associated with some of those bad events. It may be mentioned in your team's calls to replace the system. Your managers may be reporting problems retaining your developers or recruiting new ones. And the candidates that you are interviewing, well, we've heard of them opting out for other opportunities where they may, when they learn that the software system that they would be working with has, some of these characteristics. Or you might be experiencing instability. If changing something breaks something in a seemingly unrelated part of the system, then your staff starts to become hesitant to make changes. And so these are symptoms that we all see, but there could be root causes lying under the surface. And some of the root causes could be lack of maintenance, because we've certainly seen systems called legacy that were written in platforms that are out of support. And we've also seen .NET C# systems being called legacy systems. But anything that you don't maintain is going to start showing its age. And we certainly see classic cars that are maintained really well, cars from the 20s and 30s and 40s that are maintained really well and run really well, and they're beautiful cars. And we've also probably seen a car that's 5 or 10 years old that hasn't been maintained well, that's already headed for the junkyard. So that maintenance is certainly a root cause in a lot of cases. For personnel, Perceived lack of opportunity is often a root cause, that they are figuring out where they can learn, where they can grow the most in their career and take the next step. And if they look at your opportunity and look at the system and the mix of patterns and methods that are used in it, as well as the technologies, they're making that judgment call. And then in addition, we often see a root cause around an insufficient development environment, meaning you have this really complex system, actually, regardless if it's 30 years old or if it was written 5 years old. Either way, if there's an insufficient development environment, then it's going to be slow to change and hard to work with, and that can be a common root cause. So let's look at how we can proceed. The 3 strategies for modernizing an application are here on the screen. They're finding a package to replace it with, rewrite the thing, or fix the problems and upgrade it. And regardless of shades of gray, these essentially are the 3 strategies that you can choose. You can execute each a little bit differently, but these are the 3 strategies. You're going to pick one. Well, we'll ignore the 4th strategy, which is essentially to do nothing and wait out the problem. Each of these does have some benefits and drawbacks. The package replacement, for instance, promises, the vendors, they promise to be the quickest to a full replacement because you're not developing the whole thing, you're changing over, but you have to do a lot of customization. But so it's still not quick or cheap. And for all of these, we're talking about 7-figure budgets here. For any significant system, you're talking 7-figure budgets. But the package sellers, they tout the faster timelines than a full custom rewrite. And in a lot of cases, it's hard to argue with that. You could rewrite for the 2nd strategy. You could rewrite in a modern technology like C# and Azure, or you could, 3rd strategy, fix the problems that you are having with the system. Now, the 3rd strategy, in a lot of cases, might seem far-fetched. The fact that you're looking at the first 2 strategies is probably because your people have tried to fix and upgrade things through the years, and you still find yourself with a system resistant to change. And so strategies 1 and 2 look promising, but the duration that you have to wait until real usage, well, that's a problem. If you can't change your system, and that's the reason you're looking at strategy 1 or 2, then you have to wait until an alternate system, whether it's a package or a custom rewrite, is ready. And dates that people throw around, if your investors or the overall business leaders are asking, you're not giving them a small number when you're estimating how long that would take. So you're still talking about a significant period of time. And that's problematic because your business can't just sit around and do nothing and make no changes. And these are big, significant systems. So let's figure out how to see some of the value quicker. If we can segment the system and do some interim releases, then we can capture value quicker. We can accelerate the pace at which some group of users could start using the new version of the system. Again, regardless of strategy, let's hybridize this a little bit. So if we're doing a package replacement, could we implement some significant modules and then take the existing modules offline and then integrate the old system with the new system? Now, some of you just probably threw up in your mouths a little bit when I said integrate the old system with a new package system, because what does that mean? That means changing the system that you have. And if you shy away from the fix and upgrade paths, because it's kind of hard to change the system that you have. But if we're going to have a release where some of the new and some of the old are in place, then we have to be able to change and refactor our existing system in some way. So we realize, actually, when we're getting down to it, that regardless of the modernization strategy, we have to regain control of the system that we have. Otherwise, we're going to commission a long and expensive project and set up and plan a highly risky big bang cutover event. And we all know that these types of projects love to fail. The longer the project schedule, where, oh, we're going to work for a long time, and then sometime next year, we're going to actually have people use what we've been working on for over a year. those projects love to fail. And I'm not here to sell you on a strategy. All of these strategies are viable, and clients are doing them all the time, all three of them, and actually the fourth of doing nothing. But I'm here to tell you that even though you have an aging legacy system that's hard to change, you must do what is necessary to regain control over it. And if you don't, you're sunk. So let's talk about how to regain control. It's more than just having a way to execute changes. This change cycle here on the screen probably looks familiar to you, and it revolves around a way to build and deploy the software, but it's woefully complete. And again, planning, coding, integrate, package, release, operate, learn. If any of you are using Scrum or Kanban, or are actually pulling in some DevOps methods, that looks pretty familiar. And you need to have some way to make new builds and redeploy, but it's woefully incomplete. And if this is all the model that you're working with, then you're not going to be able to regain control over that system. So let's talk about that a little more. To execute our modernization, again, I'm gonna talk about this every single slide. We are regaining control over our system, because once we regain control over our system, then we can choose the strategy that's appropriate and execute it in an incremental way. And we have a model for that. So regardless if your system might happen to be COBOL or just older .NET, or even if you have a poorly designed system that you just inherited, you need to be able to change it. And so the center is the foundational infrastructure necessary to make changes and redeploy them. That is that black center, the automated DevOps pipeline. But there are other layers of capability that are needed just as well for a modernization. And you'll use these to regain control of that system during the entire modernization as you make some fairly significant architectural transitions. So of these layers, and we'll go through each one of them, of these layers, each must have a sound strategy, be executed with discipline, and have objective measures. And we're going to go each layer one at a time briefly. But those are the three different things. You have to essentially choose your strategy, just like you're choosing the strategy in the modernization. Choose which path to head down, then plan and execute faithfully. And then you need to measure your progress and make sure that you stay on track. All right. Now, before we go into the layers, I want to show you the basic structure of any automated DevOps pipeline. And you absolutely must have one for every application that you manage, aging or not. Not having one almost guarantees that it will show its age as soon as the original developers leave your company. This, by the way, on the screen is part of a larger design poster. And if you post in the chat or just follow up with us afterward, I'd be happy to send this DevOps poster to you as a full-size PDF. And it's formatted for Architecture D paper so that you can print it on a plotter and hang it up if you like. But you can just throw in a message in the chat if you'd like to request it, or send us an email or follow up afterwards. I know that you can't read all the text on the screen. There's a lot of it there, but that's why it's such a big poster. But it's a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy, with continuous integration build, a 3-tier deployment pipeline. And for any pipeline, you'll never have fewer than 3 environments. You have 3 types of environments. You have production, you have a manual test environment, and you have an automated test environment. Now, you may have multiple manual test environments or multiple automated test environments, but those are the 3 distinct types. Even for simple applications or microservices, you're going to have this structure. And so we've done some other webinars that dive deep into all the details of this model. So please reach out if you need more information on how to set up this software for an automated deployment or continuous integration. But just let us know. Again, no matter if your system is really old platform, or just an aging design, your environment starts with this basic foundation, this basic infrastructure. And you'll continue to have a very hard time making any changes without this. All right, moving on. So once we have the basic mechanics to be able to make a change, and again, we can test it by just making a text change. If you can just change the text on a button, and then make sure you have the capability to rebuild and redeploy and move through that cycle really fast in an automated way, then move on. Now, for a modernization, there's many practices available to you, but there for just general development. But there are some of particular usefulness in a modernization, and some practices on the left. Those are just sample practices. The list of available practices is a mile long. So um, one is feature branching. So in a modernization, you want to be able to make every change be small, because again, you're probably used to the environment where you make a change and something in a seemingly completely different part of the system breaks. And so you need to be able to make a change, and if it didn't work, back it out. So feature branching enables the small changes. And when you configure your DevOps pipeline so that every feature branch has a build and every feature branch has a deployment to that first line test automation environment, well, now you have the feedback necessary to know if some change that was just made things worse. Then you can back it out and make sure that you don't merge that feature branch back into master. And by the way, even if your system is on an older source control, Subversion is very compatible with the DevOps process. TFS version control can be made to work, but also source control is one of the easiest changes to modernize up to Git source control. It really is. The other pattern that you're going to want to bring in really, really fast is refactoring. And you've probably heard of refactoring, but it's not just changing the code. Refactoring is a very specific way to change the code. It's improving the structure of the existing code without changing its behavior. So the user shouldn't even be able to perceive that anything changed if it was a refactoring change. And you do those on feature branches. And the goal is not to change anything about how the system behaves, but to improve the structure, to maybe give you a seam so that you can integrate somewhere or separate out some particular functionality. The third practice that is really, really, and I've already actually talked about it, really, really useful and needed in a modernization is continuous integration. And that is bringing together changes of various people so that no single change is large. That means nobody should work on code for several days or weeks on end. That means that you need to impose almost a standard of checking in multiple times a day. And any check-in, it's kind of like the doctor's creed: first, do no harm. With continuous integration, the first thing with code changes is do no harm. Make your changes in a way that do not destabilize. All right. So there's plenty of other practices, but those three are absolutely so useful in a modernization. But you need to choose the practices that you're going to go through. Okay, so big changes happen during modernization. And one of the things we need to be able to do is to find and prevent defects. And we already have a system. This is different from building up a new system from scratch. We already have a system. And chances are, if it's an aging system, it doesn't have automated tests. It doesn't have automated validation. And so we want to start with covering tests. Now, if you're building a new application, you might start with unit tests. Then you might continue with component level integration tests that are a little bit larger. Then you might continue with full system testing that covers large swaths of the system. When you have an existing system that you're regaining control over, you do the exact opposite. You do not start with unit tests. Frankly, a waste of time, because the code is probably structured in a way that makes it very difficult to unit test. That's probably why you haven't done it. Start with covering tests. Start with tests that run against a fully deployed environment, and that actually drive the screen and act that actually do the same things that a user would do when you're driving the system manually. Type things into text boxes, press buttons, and then go look at the database to make sure that a new transaction was actually done. Things like that, covering tests. Because then what's likely to happen is you make a change and then somebody reports, hey, this function or this screen isn't working anymore. Well, if you cover your existing system with these covering full system tests that are run on a fully deployed environment, then you find out right away if you just broke a function of it, or one of the main pieces of functionality. And it's different from unit tests. Unit tests pinpoint exactly where the problem is and it exercises only a small bit of code in the system. The covering full system tests execute lots of code in the system. And when they fail, it tells you, hey, you did something wrong, undo it in a hurry. But it doesn't tell you exactly where you went wrong. So the different nature of tests, different types of feedback, but you want to make really small changes. And so when one of those covering tests fail, you just undo the change that you made. And again, all of this should happen on a feature branch so that you're not actually destabilizing the main line of the system. You're deploying the builds from your feature branch. And so these covering tests are executing and you get really good feedback. Second is you want to do formal recorded regression tests. Now, if you're using Azure DevOps Services, then you can use Azure Test Plans, and it has a Chrome extension. Really great. You can have your users or stakeholders do their manual testing sessions, and they can just click a button and it'll record a video of their testing session, and it can just attach it to the work item. So that's really great. But either way, you want to have formal recorded regression tests, because even if you start with covering tests, you're not going to cover everything. And then we'll talk about this next in our team workflow, but you want a definition of done. For each refactoring, for instance, I would suggest that you add this to the definition of done when you're making any kind of change. If the change is a refactoring, then part of the definition of done is that covering tests must be developed for the part of the system that is affected by the refactoring, and add other things into the definition of done to keep you safe. And that's just some of the high points on defect removal. But there's, again, Capers-Jones's research shows that there are 3 defect removal techniques that together give you the best bang for the buck, and that is testing, inspections, and static code analysis. So you can get all kinds of static code, command line static code analyzers to run against and find some problems. Now, you're probably not going to fix every one of them because that would be just a huge scope if you've never done this against your code base. But inspections are a pull request process so that when changes to a feature branch come back into the main line, that a different person is actually inspecting to make sure that the definition of done was complied with, for example. The next layer is team workflow. And with team workflow, again, we are getting back in control of our software system. You want to add extra columns to your Kanban board. So everybody these days works with swim lanes. You model your software development lifecycle with swim lanes that are essentially the statuses. Now, in an incomplete workflow, it would be not started, in progress, done. Well, that's woefully incomplete. But in a lot of cases, people have analysis and design and development and pull request and testing and deploying and then done. But add extra columns to your Kanban board ahead of making the code change. One suggested column would be an actual column to spend time, quote, understand user scenarios. If it's an area of the system that your team hasn't really done a whole lot in, then yes, it's appropriate to actually move that card over to the column and spend time with the users to understand how the users use that part of the system, do some screen recordings of them exercising those transactions. Also, another column that's going to be really important is an actual column for adding those covering tests, adding those full system tests that cover the large part of the system, and have that column be before your development column or before your coding column. Because in order to make a change, you need that safety net, and that's your safety net. Again, with a modernization, we need to adopt the doctor's creed. First, do no harm. We have a big system that is too big for any one of your team members to keep in your head. And so we have to create these methods and these assets that help us stay safe. We don't want to kill the patient. We want to heal the patient. We want to help the patient. So if you've had staff turnover, your people likely won't be that expert power user and how the system is used in various scenarios. And so just talk to the users. Okay. So that's the workflow changes along with modeling the rest of your process, but specific to modernization. Now, architecture blueprints. We need to know the shape of our current system and the shape that we're going for. If regardless if we're rewriting it or if we're fixing and upgrading or if we're replacing it with a package, there's going to be some changes. There's going to be some outside integrations. We need to know the shape of the system now and the shape that we're going for. In 1995, Philippe Christian from Rational Software wrote about a model for incremental architectural blueprints, and he called it, and you can search for this online, architectural blueprints, the 4+1 view model of software architecture. And even though it was in 1995, it was a model for iterative emergent architecture that was constantly changing rather than big bang waterfall architecture. So update the 4+1 architecture, and then, well, if you have nothing, then go to a whiteboard and get with your team and harvest it. You need the physical or the runtime layer. What do the environments look like as it's running in production? The logical layer, what are the directions of dependencies, and what are the logical modules inside the system itself? Then the process layer is, in what way does data flow through the system and its different components? And then the development layer is what's necessary to actually develop on the system. Think of if you're onboarding a developer to the team, you tell them, oh, you have to install this on your workstation. You have to configure it this way. And there's a whole host of things to do so that they can get ready to make a change and understand how to do that. That's the development layer. And it's just like having the electrical layer or plumbing layer or HVAC layer or floor plan layer in blueprints for a building. There's lots of different views of the same structure that we have. Same thing with software. So update that 4+1 architecture for yourself, and then cast a vision for what the system will look like when finished. Create a to-be architectural set so that you can get everybody aligned about what it's going to look like. Then draft transitional architectural states at each milestone and use this to align the team and for you to inspect what's changing as your team executes through this. And so you can have, if you need to go through 7 different architectural transitions to get to the finish line, well, kind of do some brainstorming and think about what would be important at each step. There's going to be changes, and if it's a replacement, whether with a rewriting or replacing with a package, certain things in the system are going to go offline at certain milestones. So it's good to represent that if that's the case. A replacement pattern, by the way, is the strangler pattern. And this is whereby you refactor parts of the system to disconnect them or to take them offline one at a time. And then you just leave the code there, dormant. In some cases, it can be less turbulent to just disconnect and leave dormant code than removing the code. If the act of removing the code causes the structure to begin to crumble. And now this is a judgment call on your own. In modern languages like C#, if code is dormant, then you can just delete it and it's no big deal. But in some other platforms, the file structure and whatnot, it's a little bit harder to do that. So, but anyway, for architecture, strategically, you're defining what is being changed, what it's going to look like, what we're investing in now, and what's being deferred. Every professional that builds something or works with a building uses drawings to communicate that. And so this is no different here. Now, the next layer is cloud operations. This is the same regardless of any operations, whether you're in your own data center or whatnot. It's more modern operations. You want to assess the state of your logs and your capability to observe the system. There's that watchword, observability. If you don't know what your current system is doing, then it's a mystery to you. And so whether or not your system is aging and you call it a legacy system, or whether it was just developed last year, you still need to be able to observe what it's doing. And then add more telemetry. Provision a centralized log and an analysis environment. If you have existing text logs, you want to copy them off to a centralized log data store, and then start creating some queries so that you can analyze what the system is doing. And if you find that you don't have enough logs in a certain area, go and add logs, add telemetry, both statements, messaging statements in text form, as well as numbers like performance metrics and counts. Both types of telemetry are very useful to understanding what the system is doing as we start to change it. And then in your operations stable, recreate an environment. I know some of you just your blood pressure just raised when I said that. But recreate, force, maybe assign one of your team members to figure out how to recreate an environment. If that's been a challenge for you, you need to prove to yourself that you can recreate a production environment. If you can't, then you're just one step away from an outage turning into a disaster. And it'll force you to learn what's required to automate the environment recreation. Because once you can do it and essentially create a set of steps to recreate an environment for the system to run on, well, then you can automate the creation of that environment. And again, we are regaining control over a software system that has dogged us for a long time. The original developers are gone. There's so much knowledge that's walked out the door. We're kind of scared to change it, and we try to stay away from it. But regardless if we're going to rewrite it or replace it with a package or actually spend some time and money fixing it and upgrading it, we have to regain control of it, regardless of the strategy that we've chosen. Okay, so the perceived easy way out of a legacy system that's hard to change is to avoid it. But if you think that you're going to build something up next to it and then cut over, that type of project is easy to talk about, maybe tempting to go towards it, but they don't work out. Let me give you an analogy in nature. So on the plains of the Midwest, where there's buffalo and cows and both types of animals, sometimes the storms come across, and they come west to east, and the cattle, they see the storm coming and they start moving east and they start moving away from the storm. But then the buffalo, they see the storm coming and they all start moving west towards the storm. Now what happens is the storm's going west to east. And so the cows that are moving away from it, they're moving away from the storm. But of course the storm's moving faster than they are, so the storm catches up to them. But because they're moving east, they end up being in the storm longer, and they are wet and cold longer. The buffalo, yeah, they hit the first raindrops of the storm first, but because the storm's going west to east and they're going east to west, they go through the storm and they actually get out of the storm faster. And so it's the same thing with modernization. Regardless of the strategy that you pick, you have to be able to change the system and have enough control over it. So be the buffalo. So some examples how we've helped clients go through modernizations are on the screen. We'd be happy to share more with you, but there's one on the left, Gladstone. They have 80% market share of the mid-size fair market, and they needed to modernize up to the Azure data center for their software system. A significant complex software system. And they were having some other issues, but we helped them through this process. We helped pick a strategy, which actually was the fix and update strategy. It wasn't a replacement. And if you're wondering what strategy to pick or wondering how to plan, just give us a call. We'd be happy to help you as well. We have two models, and the first model is helping your team be completely self-sufficient and coaching you through that. The other model, the guided model, is where we come alongside you and guide you through the modernization. And so we could start out with an assessment, a review, a modernization roadmap. One easy way to get some help is to have us do some architect level advisement or consulting. I love to do that personally. And if you'd like a second pair of eyes on your system, validate the strategy that you're picking or some of the key decisions, happy to help there. And we have some contact information on the screen. So this is my direct phone number and email address. So you can reach me pretty darn easy. I'm going to look at the Q&A window now to see what questions we have submitted, and make sure that we have all the questions answered. Again, after this, I'll be hanging around for a while after the webinar is over if you want to call me directly and have a chat. So let me look at the questions that have been submitted here. Okay, so here's one from Alexander. How about a legacy database with store procedures and a big amount of tables? Are there any practices of how to start splitting that into different ones for different services, or if it usually is not worth it if the database becomes a single point of failure and bottlenecks? Good question. Good question. So the database absolutely has to be part of the DevOps pipeline. It has to be part of the build. It has to be part of the deployment. Now, architecturally, you have the architecture you have now. And so you need to regain control of what you have now, including that database with way too many tables and way too many stored procedures. Regardless of how big your schema is, there is a way to deploy it and recreate it. And so you want to get started. You want to get started from the middle of this onion outward. And if I move over a second, you can see the automated DevOps pipeline behind my head. You want to get that for your system. And then once you achieve that and go through these other layers, then you can start a much quicker cycle time on that big complicated system that you have. Then you start with the architectural blueprints of what it would look like to split it up, which tables would go where, analyze the foreign keys, how you would segment that out, create a 2B architecture, probably in Visio or whatever drawing tool that you prefer, so that you can get your whole team aligned with what a segmentation would look like. If we have this big thing, we want to split it up into two things or multiple things. Let's start drafting the architecture so that we can pick a structure that we think is going to be successful. Then we have the existing architecture, and then we have our 2B architecture. We need to start enumerating some milestones along the way that we think would be viable architectural transitions if it's that significant. And then we can go from one transition to the next, keeping the entire system stable all the time. And it's important before we actually develop or to change any code and start making these transitions that we add our covering tests so that when we deploy the system, we can run this suite of full system covering tests so that if we go awry, we can immediately be notified and then take a step back and then step forward. But yes, there is a way to do that. Actually, most legacy systems are big and ugly and have really complex databases as well as business logic and all kinds of dependencies. They have pretty much one of every type of thing you want to get rid of. And you do have a bus factor with maybe one or two people who might have learned it more than the next. But the key is to equip yourself with an entire environment so that you don't have to have one or two key people who know how to deploy the system, but you equip yourself with a automated DevOps pipeline so that the system essentially deploys itself. Looking in to see other questions to make sure I don't miss any. And again, please take a screenshot of my contact information. Let's see. Some people are asking for the poster in there. Yes, absolutely. Just make sure that Rain is looking through the chat. Make sure that she has your name for the poster. Okay. All right. Another good question that just came through. Let's see. I'll take it one piece at a time. What is your opinion of branches based on environment? For example, having a dev branch, test branch, etc., where you merge code over to a branch that has a build that goes to a deployment. Just a long question, but I want to make sure to rephrase it here. Okay, generally speaking, I'm going to talk about the 80-20 rule. And if you have a reason for straying from the 80-20 rule, then great, because you have a reason. But the general rule of thumb is that you build once, deploy many. That means that you build off of a branch and then you deploy to multiple environments. And yes, we have seen many clients who have the build many, deploy once strategy. Um, our recommendation for a rule of thumb is the build once, deploy many strategy, where you build version XYZ off of a certain branch, could be master, could be a feature branch, and then you deploy it down the line until it either makes it to production or it dies and it never gets to production. Now, by definition, builds that are executed on feature branches can never make it to production. They die after the first deployed environment where you run the full system tests. But if there's, and then once you realize, oh, my feature branch is good, let me do a pull request and let me merge it into master. Then you have continuous integration executing on master that does a build, and those release candidates can make it to production if they don't die before making it to production because a showstopper bug is found. And so they go through the progression of environments. Now, what we see is in the absence of a good environment and good tooling that can keep configuration information and secrets that change from environment to environment, a lot of people have resorted to using source control for storing environment specific configuration details rather than having that be in a release management system. When a good release management system is in place, then a lot of our clients have found it just drop dead simple to adopt the build once, release many strategy. And so Azure DevOps Services and the Release Hub within Azure Pipelines, that is a good release management system for the really complex deployments. Octopus Deploy is a really good release management system. And both of those are designed for the build once, deploy many strategy. So great question. We see that we see that out in the wild quite a bit, and it tends to add, when you adopt the build many, deploy once, where you essentially rebuild the software in order to deploy it. That introduces additional complexity that's just not necessary, and ultimately leads to a situation where one or two people are the only ones that actually understand the deploy system, and kind of create some silos there. If I didn't answer all of the question, go ahead and repost or just reach out to me, and I'd love to talk to you about it. Okay, I think that is all the questions, and I think we're 43 minutes in. I appreciate your time and attention. Again, this is my direct phone number. I'd be happy to talk to anyone who has a follow-up question or would like essentially some free advice about modernizations. These are hard, complex, risky projects, and I hope that the information today gave you some clear direction on how to approach your modernization. Have a great day, and we'll see you next time.